So, hi everyone. Nice to have you here. Today's webinar is about TDD in the age of AI. I want to start with how I got to this. Like, I'm a huge TDD fan. I worked in TDD, like on whole projects. I believe that TDD is the best way I know how to produce working software over time. So, the one of the last webinars I have, the one with the one I prepared examples for BDD. I started playing with the idea of like generating stuff and generating tests and generating code, stuff we're going to see today. And what caught my eye is that at one point I had tests that were not passing, and this was like in JavaScript. It's important because today is going to be in Java, and I asked Copilot, please generate code for my class, and it did, but I ran the tests, test didn't pass. Said, okay, tried it again, like generate code that passes the tests. And it did, and it was like a magic moment for me because I know most of you have worked with ChatGPT or whatever LLM that you were working with, and you know that it's not like exactly how we want it to do. But the thing is that this kind of magic of how it did it, I don't really know, but I'm guessing like uploading both my code and my tests to the cloud, doing stuff there. It didn't run my tests on my machine, but I got working code. So I started thinking, well, first of all, this would be like a nice webinar to do, and thinking about like how can we take this forward? Now, I'm going to start by saying we're doing this in March 25. This is not about the quality of the code or the things that we can generate from. Different engines will give you different answers today, and I'm sure like in 3 days or 3 weeks or 3 months, things will get better. So this is not about can, in my case, ChatGPT generate code for my test that works, because fortunately in Java I didn't. But I'm sure this will be improved over time. More important things, and in my view, and this is what this webinar is, it's on how TDD and how we change in the process. It's a big introduction. So what's more important than TDD? Me. So I'm Gil. I'm a trainer, I'm a consultant, and I work with people who want, developers, testers, who want to make their software better, and TDD really falls into this this category. And I'm thinking like AI really falls into this category because you want to make the code better. So you like I said, I might be a bit sarcastic about this, but this is not about how good or bad the tools are today. It's more about us. If you are interested in the things I do, like for example, painting roads, or training on TDD, unit testing, automation test, whatever, let me know and I can help you, I hope, with or without AI. Okay, so for the people who are not that familiar with TDD, I'm going to spend a couple of minutes about what TDD is, but I'm going to start not with TDD, but test first as a family, where BDD, behavior-driven development, or ATDD, which is acceptance test-driven development, and going back to TDD in a minute, which is test-driven development. I want to talk about why it works, and it has a couple of ideas that that has it, but the whole idea of test-driven development, or the family, is that you spec out what you want to see at the end. Like it's not like regular development. It depends if you're a developer and you grew up and learned development in university or in college, school, or in the street. You are taught to build stuff and then check it. Test works differently. You first spec out what needs to be done, and then you fill it up just based on the requirements, which basically it works because it kind of focuses you on filling up the requirements with just enough code. And it has a lot of like flavors, like I said, BDD, ATD, all kinds of things. But the main thing is that, yes, you need to build this for this. And this is how we know that everything works based on the assets that we have in the tests. TDD was there before a TDD. Well, depends on who you ask, really. But TDD is more of a method of developing software. It's for developers where they write tests before they write the code. It's usually most of the time involved with the unit testing world because of its space. So how does it look like? Every example on the internet, including mine today, will be about calculators. So you probably have seen this thing before, the red-green refactor cycle, which is you write a test, the test should fail because it wouldn't compile or the code is not there. Green, make the test pass. It's make all the tests pass, really kills. If you actually break another test, it still doesn't count as green. And then you have the refactor. So a calculated example looks like this. You write a very bad named test, and you see the squiggly lines under the calculator, and the calculator is squiggly lines under it because there's no code for the calculator class. So you add that. So you have like no more squiggly lines, not for the calculator, not for the add method. And you actually think about, well, let's skip back in time. How do I call this calculator? It has a method add. Let's conjure this method, and it has two parameters. This is where the design, test-driven development or test-driven design, you actually design the code that you're working with. So you have this, and you have fill up the code, calculator, add, very simple. And now that you have this, you refactor, you didn't like on the green the I and the J, so you refactor the code with first number and second number, and now everything's cool, and you can move on to the next test. And most examples actually finish with that, which is kind of bad because like who writes calculators? I want to talk about something that we'll see at the end, and this is about the separation between the green and the refactor, which is make it pass, green makes it pass, and refactor is make the code better. The definition of refactoring, again, depending on who you ask, but mostly is changing the form of the code without changing the functionality. How do you know that you didn't change the functionality? You have tests for that. Do you have enough tests? Do you have the right test? We're not going into that now. But basically, there's a separation, and it helps in a lot of ways. The major one is that, again, it's the human thinking. How do we focus? What we focus on? First, we focus on making the tests pass. Then we focus on making the code more readable, more maintainable. Usually, without this, we try to combine this and other things in our head, like performance and all kinds of things, like try to mesh up everything to make the greatest code that we can. This separation actually helps us do something, and it will actually help us when we talk about AI stuff. So calculator, the example would be about calculators. I want to show you first something that is AI related, but not TDD related. And what I did is took code from a calculator. Let me show you. This is my calculator, which I dislike, but it is a good exercise for doing refactoring in my classes. Two APIs, press and get display. That's it. And I just asked Copilot to generate tests for me. It's not TDD, of course, but I wanted to at least see what's going to be the difference, at least in experience, kind of tests that it does. So and look at what I would change, because this is like stepping into TDD in the middle. So the first thing I did was like right click on my calculator class and tell it to generate tests for that. And you see the test that it generated, display 0 initially, display single digit, display multiple digit. Note that I didn't give it any requirements. So it sort of like move on from the code. Okay, display error on overflow, which is kind of a nice idea. Like if you're thinking about it, you have two methods. It kind of encompasses things. Um, it knows that it checks that 2 plus 3 equals 5, which is nice. It checks that 6 equals divided by 0 is giving you an error message, which is wrong. So if you run this, you'll see that it's not. The code is actually gives you an E. Um, and okay. Um, and this is like a sort of an advanced thing, because it doesn't have the code actually does this, but it's not in the code. So it's not a case that I wrote the code to work with. So actually, this kind of passes by accident or something like that. I tried another thing, which is I went to the prompt, asked generate tests for the class, but make sure they pass because this one didn't. You can see that it sort of repeated itself. This is still here. It kind of added a couple more things, like reset after operation was the last one we saw, but it also perform subtraction. No code for subtraction in there, so it fails. Same for multiplication, clears display. So obviously, the code was not the only source for that. So the thing about trusting your sources is something that um, we need to be aware of because we don't know where the sources are. But a lot of examples calculated on the internet, including mine. But you can see what you get just by asking for tests. I did another thing. I took the generated test, but I started looking, well, how would I write them? So this is like going over the first ones, and I did a couple of things. First of all, I fixed the failing test, and I created a common setup. You saw that I'm using JUnit. It didn't create a setup for me, so I did that. A common setup. The names, I like a convention like this: on pressing key display it, on pressing multiple keys display all, something like that. And naming will be like something that you'll need to either train them on or go in and rechange. And I use like using assert that rather than assert equals, which again you can tell what the prompt that you're using. Okay, this time use that. And we'll talk about them, how much you're going to fight the prompt for that. And I added a couple more tests. Which tests are those? Um, total, like pressing a digit, operation display doesn't change, like 4 plus, you get a 4, and 0 plus, and you get a 0 because the operation doesn't change the display, and 1 plus 3 shows the last digit. These are things that are in the code, but as tests or cases were not generated the way I would do it, and we'll talk about that as well. And finally, I have another one. Yeah, this one's like a bit more, even more advanced. Pressing operation after a digit shows the last digit. It's more like this, but more advanced. Again, it works because the code is supposed to do that, but the tests that sort of would have driven it are not there. Okay, so let me get back to the slides first. I want to talk about control, because TDD is a lot about control. You control the tests that you select to do next. You control about the design of the test. You control how much code you actually add. You think about how big the steps that you want to jump. So it is a lot about control. You also decide on the semantics of what you actually want to present. Example of test that I showed you that I would write is an example of how big of a step is it and how what I would write next. This is TDD is a bunch of skills bunched up together, but it all goes back to I'm controlling the process. At the moment we're putting like our companion, copilot, whatever, computer, AI in there, we're losing control. So it's not like we're going to get it back, but it's sort of like we're fighting for. And this is important because we're going into something that if you were doing like a pairing with someone else, like there's going to be a discussion, understanding why you're doing that. So this is like something that you're not going to do, especially if you're doing it with yourself. So let's move forward. Remember this thing, we'll get back to it at the end. I want to give like a PSA before we're starting out. If you already probably have tried to generate code and tests in different ways, you already know that smaller is better. You have to define your problems. Like if you try to generate like build me a system that operates all my audio machines and lets me manages the visual stuff as well. It will not work, obviously. So you will try to say, okay, I'm going to work on this part of the problem, which makes you not a developer, it makes you an integrator, but okay. And this is something that is true for TDD as well. Part of the control I was talking about is about like trying to say, okay, I'm not going to do the whole thing in a big jump. Let's try to make the steps smaller so we can see the progress and get feedback. I didn't say that. One of the things that TDD is famous for, when it actually works, is that the feedback cycles are quick. And that means that you have like a new passing test, like every couple of minutes, 10 tops, something like that. So you actually feel the movement forward, which is not necessarily true for ATDD or BDD. Like here you can have tests that stay red or failed for hours or days or weeks. The thing is that it kind of gives you a level of progress, you know, a feeling of progress of what how you are far further from what you actually want to have. So going back, small steps always works. Smaller the better. So you need to cut down the tasks. And in TDD, we say, okay, we're going to focus on this test, and we're going to focus on this next test, because this is what we're going to tackle. One of the calculators mostly don't have a lot of dependencies, but your real software does. And a part of having like this small things is smaller dependencies or smaller number of dependencies. It will be better, or like it will move quicker and with less round trips, with less dependencies. Again, you can define a lot of stuff in the beginning and run with it. It's not like classic TDD where you design the interface in incremental manner, and you can usually get to a point where the prompt will actually give you what you thought you wanted, but the less dependencies, it will go a lot faster. This actually goes into something that you may know from clean code, for example. Less dependencies is better for everything. I actually had a discussion about that this week about people who use .NET Core, and the whole thing is dependency injection infested. They conjure up dependencies like there's no tomorrow because the system let them. And this is something that if you were like knew about better design, stuff like that, you would minimize that. You would use adapters and like separate the adapters and dependencies into something that the code really needs. And if you're doing 2DD for a while and well, these are the things that you think about while you're doing this. And again, this is something that if you're working with a person or with yourself, you'll have to explain it to yourself or the person. If you're not, you'll have to explain it, I want it like this, the prompt, and maybe not you will get what you want. Again, this is not about the quality of the generated code. This will change. What else? Yeah, don't trust it ever. You need to review, like I did, and we're not at the point of trusting whatever we're getting. So we'll need to review, and some of it will be like, this is not how we do things here or how we write code here. Some would be like preferences, like I don't like the names you're suggesting. I know how names are written by most people on the internet or GitHub. I don't like that. So be aware that it's going to be like it's going to be not as smooth as you think TDD is. So let's see what I did in terms of demo. So let's jump back to the code. So what I'll show you is what I did in terms of a couple of steps of generating stuff. So let me shut the first one here. And the first thing I did was I went to ChatGPT and gave it this prompt. So this is I'm starting from scratch, no code. I'm coding a calculator in Java. This calculator has two APIs. So I'm telling it the APIs that I need, something that I would write in the tests. Press and get display. The calculator has the following rules. It can accept any digit key. It can add and divide. And I went back to my exercise, which was not complete because it didn't have like multiplication and subtraction. It presses a single key, sent as a single character. It has a plus, div, and equal keys. A display is more than 5 characters, it displays E. If dividing by 0, it displays E. If pressing a digit, it shows the digit. If pressing plus or div, the display doesn't change. Pressing equal displays the calculation result. Please create a set of tests that check the implementation. Do not create the implementation because this is like test generation. I don't want TDD. So I asked and I have received, and I just added a calculator class here. So things will compile. I didn't get a calculator class from that guy from ChatGPT. So let's review what he got. So first of all, it gave me before each a common setup, which I liked. Yeah. Testing single digits display, test addition, test division, and you see that it happens a lot. I'm guessing because it's a calculator, it's going to be a lot of guessing. That it jumps into the equal part because most calculators examples are focused on the equals, like the calculation themselves. Can't be sure. So I have 2 plus 3 equals and test division. I mean, the examples are in the assert equals rather than assert that. Test division, test divide by 0. Okay. And this time it is according to requirement. Let's take a look at this. So it generated a bad test. What is the bad test? So display exceeds 5 characters. So the requirement, well, it was if the display is more than 5 characters, it displays an E. So what it did is did 1 plus 2 plus 3 equals and an E. So if you're a human, you would understand that this is supposed to present 6. And you could say, well, I gave you all the requirements. Why didn't you do that? So again, I'm not saying that this is a problem today or tomorrow, but this is going to happen. Like this is our companion not understanding the semantics of our problem, and this time the display exceeds kind of created a bad example for that. It went even further for that. It sort of given interpretations. Let me give you examples. So first, test consecutive appraisals. So it did 4 plus plus 5 equals error. So this is not in the requirements. And in my clean code classes, I actually ask, well, what happens there? Because there is no requirement on what happens when you do an operator twice. And a lot of discussion goes in there and so on. But this is an interpretation of a good case, but the interpretation is it's supposed to return an E. Does it? I don't know. I need to review. Two more like this was equals return an E, and 4 plus equals returns an E. These are things that are not directly from the requirements, and some of them, well, I need to think about this, and at some point maybe I will. But the main lesson here is like, look at what it created because it may not be what you want. For example, if it did, which it didn't, because if it did for plus minus 5, for example, this is something that comes up. What is the meaning? Is it an error? Is it something that I should consider the first plus? Should I consider the minus because the first plus was an error? So there's a lot of semantics of how you use a calculator that go in there. Obviously, with your examples and real code, it's going to be a lot more complex than that. Okay, so did that. And then I said, well, generate tests, generate code from the test. So I went to the calculator and said, went to the my prompt, copilot, and I said, generate the code for the calculator class based on the first test in my calculator test list. And it created a lot of code. Should you recall, this is the first test. Press 5, return 5. If you've done like TDD for like 5 seconds, you know that the code that returns this is get display, return 5. You don't actually have to do this, but you definitely don't need everything in there. So I did like the next thing I would think of doing, which is I commented out everything here, except one test, and want to see if that works. So prompt, generate the code for the calculator class based on the first test, and this worked. You can see there's a lot less code here. It's weird a bit. It's not like how I would write it, because it uses a regular expression rather than something else. This means, by the way, if it's a number, it's flaky, but it passes the test, which is like what I want. So I did, let's look at the test again. Yeah, press 5, get a 5, works every time. So excellent. I moved on to the next step. The next step was to do a bit of refactoring. So what I did was I refactored this test, actually refactored with my hands, because I have a passing test. I want to see that everything's still working. So I renamed it on pressing single digit to display digit, and changed that to using assert that rather than assert equals from JUnit. And I uncommented the next test. So this is like a big jump. I mentioned that before. If I was doing TDD, the jump from here to this case, which actually does all the calculation and remembers what I pressed before and what was the operation, this is a big jump. This is not something that in regular TDD I would do. So I didn't do this in this kind of demo, but I would probably either pick some test that is a lot more simpler, because I would think like, I want to succeed in that, and like this is a big task, and I want to be in control, so I probably pick something else. But another thing you probably want to remember is that you have no idea how the order of the test generation, what you get here, it's just something that came from nowhere that no one can explain. So it's not something that is ordered by complexity or what you think about progression or something like that. So I did something probably that in real life I would not do. Was I'd say like pick this and do something for me, and I said, well, of course, generate tests for these two. Okay, so I went to my calculator, my copilot ready, and I asked it generate the code in generate the code in a calculator, which is this one. Pass the two tests in calculator test, which did this. It's less code than the original one, like pass everything. It still has this, but then I looked at it more deeply in its eyes, and I saw this block. So this block takes care that if you have like the display is 0 and you're pressing a key like 5, it replaces the 0. But if you have like 5 and then 0, it will do 50. So this is what it is. It's not in the tests, obviously. Okay, so it is similar to other examples, or maybe coming from the requirements, but going back to the requirements, it's not here. I have other examples of requirements for my exercises which say that this is like a requirement, do something and do something about the zeros, but it's not here. So what I did was tried it, this one. I tried another prompt. Generate the code. Do not generate the code that is not required to pass the tests. But it gave me the same result. Okay, so I didn't go, most of it is like probably needs to be here. It's very similar to code that I've written before in these examples, but this stayed here. So one of the things that we say that is part of the 3 rules of TDD is that you don't add code that is not required to pass the tests. And this is like a warning sign. What does this mean? I have not. I have. That means that first of all, things may not work. Like I have 2 tests. I've tested everything, and obviously this is not covered by any test. What is the meaning of refactoring code that I don't have test pass? Because usually what we're thinking about in TDD is that I always have coverage because I've written the test first. This kind of broke the circle, so it's not completely the same thing. Okay, so, but I decided I'm going to continue from here. And what I said was, well, this is nice. But you see, there's a lot of if, else, lots of nested conditions here. So what I asked was refactor the code in calculator to have a switch case structure. And like after 2 seconds, I had this. So the regular expression is gone, but I have this thing, all the digits here. This is still here. This didn't go away, unfortunately, but I didn't ask it to go away. And the rest is case plus and case equals. This is like a nested switch case, which I didn't like so much, but okay, but refactoring worked. I actually had tests to prove that they actually work. So these are still my tests, 2 tests. They are still working. Refactoring works, I would say flawlessly, but to a degree. And the final thing I did was I said, okay, let's go throw everything out and try to generate the code. So I uncommented everything. It's here. I commented out everything apart from the bad test that I didn't want. And I asked, generate the code to the calculator, pass all the tests, not generate code that is not required to pass the test, do not generate code according to the requirements, because I was not sure if it's working the way I wanted to. So it did this, which is very similar to what we had in the last one. And if you actually look, you'll see that a lot of the tests are not passing because the code is not there. And at this point, I said, okay, this is good enough for a demo. Let's see what I've learned. So what does this mean? Again, this is not like you saw examples of what I had with ChatGPT 4 and Copilot. in March 25. So again, it's not about the quality, although the quality tells us that we can't leave it alone. We need to review everything it does. The first thing is that if you're going to generate tests instead of writing them themselves, you have to have some idea about the interface that you're going to do. And this is kind of, again, in TDD, you would write a test. You kind of create or conjure the interface by yourself. And you see if it's okay for you. Even before you write the code, you can see that, oh, this is the parameter that I need to send. Is this where I need to send these parameters? What type are they? The questions that you try to answer yourself before you write the code, you have to think about them before you generate tests, because otherwise it will not have the answer for you, or a good answer for you. So like I gave it the interface, I need to give it the scope, the interface. It could be like a partial interface, like I can continue from there, but you have to have some idea about your subsystem that you're developing, its interfaces, its dependencies, everything for it to generate at least something that is interesting. Generation obviously doesn't always work, and work like has different levels. It probably compiles, at least in the examples that I've seen. It does not run the tests, although like a month ago in JavaScript, it did run the tests. So it can generate tests that and code that don't work together. You need to run the test all the time. Like you're going to do in TDD, this doesn't change. What you do when these things don't work, it's really interesting, because this is like a round trip. In TDD, you usually move forward. If something doesn't work, or you get blocked, you do like a couple of undos and restarts from the last green that you had, which, like I said, it wasn't long ago. It was like a few minutes ago. Here, like, you get a bunch of tests that don't work. What do you do then? So you probably need to do the things that you're doing in TDD. Like, okay, let's say that you actually, apart from actually writing a test by yourself, let's see if there's a test that is closer to where I am now, which will create a simpler solution for me, or like they will help me pass the next test more simply. The whole thing of being in control is messed up, and you kind of fighting for control, and you do this like you need to be in control over the code that it creates, the test that it creates, the order that it creates it in, the naming. So there's a bit of back and forth, which if you look at take a step back and look at classic TDD that you do, it kind of slows you down. TDD is sort of like, if you get in the flow, it's very smooth. This is like rough. The semantics, the importance, things that are calculator, like there's a bunch of calculator examples on GitHub, and I'm guessing it learned all of them, so it knows what a calculator does. Not all system semantics are going to be understood or understood correctly. And what is more important, not just for development, but also to make the code for, is also something that we need to be able to review. So we saw that in the tests that it generated, that I needed, with my understanding of the system, to review the tests and say, this is not exactly how it should work, or good case, it's interesting, but is that the assert that I want to write? So there's going to be like, in this case, like it's like let's say it's a plus and a minus thing, good news, bad news, because it's depending of where it generates the test from, which we don't know. Like I said, it's magic. We need to assess if this is like a good case for us, which we want to explore and see that, yeah, we need to write code for that, or like throw it away. The semantics, the test that you've created for me, is not right for this system. This is not something I'm going to write code for, because this is not correct. So be ready for bad cases, conjure that code, which can really, this is, I wanted to do something which I actually did for this presentation. I did not work with visual coverage, but I think it would be a good idea because it springs up code, as we've seen. So it adds code which I didn't ask for. Therefore, this would be like, at this point, I would stop and like say, well, probably delete the code. I don't need it right now. Make sure the tests are passing. But this was sort of easy to identify because this is a very small example and I know it and I know what's going to be in there. Like real code, trust level, low. So you want to do that. You can choose where and when you're going to fight the prompt and where you're going to take the code into your hands. It's again, these are very small examples. It depends, like you probably do this like every day in different ways. Like you get an answer, it's sort of good enough or not good enough, and you decide, okay, I'm going to continue from that or not. This is going to continue because you're not going to get perfect answers all the time. But when it works, it speeds things up. And this is like very interesting because I want to get back to I told you that one of the things I like about TDD is the separation between it works and it looks okay, the green and the refactor. And what is the T in GPT? Transformation. It transforms things in a way that is I wouldn't say flawlessly, but it does things well. So the refactoring, and you probably have seen that in other examples before, refactoring is very well. Is it the refactoring that we want, like refactoring that passes the test? This can change and probably will, but it does this very well. And that brought me to think, well, it's interesting because we kind of thinking that what our asset as a company, as a developer, is our code. But if our code can be like regenerated on a whim and like it takes a couple of seconds or a couple of minutes and you get everything back and you have proof that it does the same thing because that's refactoring, because you have tests, what is your real asset? And I'm coming to the conclusion that tests are more important than the code because code is replaceable. Tests are less so. But if you have tests that prove that this is what it needs to do, and then you have code, legacy code, that does this from 5 years ago, but you have tests and you say, well, generate the code in a new version, new framework, whatever, but it still passes the test. The code becomes less important to have because it is regeneratable, which I'm not sure is a word, but it is definitely a function. And tests become a lot more important then you do this. And in TDD, they have a different usage, right? They drive the development, but in the end, you have a bunch of tests that tell you, well, this is how my system works, and if I refactor this, that it's the functionality stays the same. Now, the cool thing is now regeneration is sort of cheap. It's for free. It's immediate, as long as you have the tests. So what else? This is like Jackie here. I was feeling like that. What's next for you and for us? TDD is not dead. I was thinking about why should I write? Should I call this TDD? Is that no? It's not dead. But it is changing, and the control part is not going away. We need control. The process is in there to give us control, and we need to use this control to take ownership, make choices, not just design choices like progression choices, where to stop, what to decide, but you see that there are a lot of cases where you have like interventions like suggestions or I didn't think about this, or if you're coming from a code that you're trying to generate tests from, it tells you, well, these cases are not covered. Plus, you have the refactoring capability. So generation can be sped up. You need to review. Refactoring can be sped up. You need to review. But you have tests. And this is, I think, the most important thing. TDD is changing. It's still working. But I think the more we do this with AI tools, we need to adapt to a less smooth function, but to finally give us, I think, bigger steps to jump from as long as these things get better. And I think we'll get better results. And this is what I wanted to share with you today. So if you have questions, please put them in the Q&A box or the chat. Use an agent and run the test in terminal every iteration. Yeah, you don't do this in TDD. TDD is something that you kind of get hooked on the feedback cycle. So if you can create like a feedback cycle, and I'm not just talking about the feedback cycle of just the test report, which is obviously something that we look at, but all the visual things that you've already seen, like squiggly lines and visual coverage. It's not just having the tests running. It's a lot of visual things that today, while we're working in the IDE, we get a lot of feedback on. Especially if you're working with another person, like do TDD in pairs, it's something that you have more feedback on. So it is possible to run things like somewhere else, as long as you get the feedback. Usually TDD is something that you don't do outside your IDE. Let's call it, as part, including the running of the tests. Is it possible to create TDD tests with Selenium before there is a website to make tests on? Didn't try it. I'm guessing that the answer is yes. But okay, so there's a big but here. First of all, you have to explain what you want to. Okay, first of all, it's not TDD. You're running a browser, things can go bad. Usually TDD is something about unit tests. But so less dependencies, less something that it's more about your code. You have to explain very well what's going to be there, how to find locators. You need to know a lot in advance. But what I would recommend is building, if you know about page object models, for example, you think about modules that contain all the things that contain the locators or stuff like that, the Selenium stuff in there. You can definitely write tests for these tests that are using these page object models because it's easier. The details are not like have to be like specific and you need to know in advance, but then you can go into the page object and define that. It's not the first thing I would do if I would generate my tests. I would usually go to something with logic and like and application rules and stuff like that, and start with there. It is possible, and you probably can generate stuff with the tools out there. If you go to if you take Playwright, for example, it can already record stuff from its test generator stuff. There's a tool which I don't remember its name. I think Playwright AI. Don't remember, like something open source, which kind of you give it like a description, like a prompt, and it will generate a test for you. It's not generated, like it's going to run it for you, so that it's not TDD, but it's you giving it operation. So I'm guessing this is going to continue in the thing that you're going to describe stuff and things will happen. The Selenium stuff, I think, is like we're not there yet. There are too many details to describe to a prompt, unless it's very simple and think that you don't have to describe a lot. Does your LLM stop paying attention to tests that you have commented out? It did in one case. Did it actually ignore it? I don't know. My pipeline commented out tests are still attended, and again, this is I've used like ChatGPT 4.0. It's like I think the simplest of the simplest. It did, but at the beginning, I asked it to do the first. So what it actually does needs review, and it probably will change. So actually, I think it's not more like copilot rather than the LLM, because I'm guessing is what the copilot runs in the ID passes to the LLM. So I'm not sure what happens there. I could like actually spy on that and see what happens. But It could be like copilot, it could be like the LLM ignoring stuff, and it could be the LLM not ignoring stuff. So don't rely on that. So this was like a very interesting experience to see where we are and how it impacts how we're doing stuff and what we need to be aware. And if my initial reaction was, it's not going to work ever, no, it's not. It is going to work. It's going to work better and things are going to change, but we need to adapt. And I think this is like something that we've done for like 97, so like 20 years, 25 years. It is changing. And if we want to get the most of it, because again, I don't think there's another method of writing software which is better, effective, productive. We just need to use the tools better, but be aware of what we're getting. If it's not working, continue manually until it does, because I think it will catch up eventually. And that's what I wanted to share with you today. So thanks for coming. I hope it was beneficial for you, and thanks for coming. The recording will be up on the YouTube channel. You can go to the YouTube channel anyway, because even before that, all the webinars are there, all my videos are there. Obviously, where would I put it? And you can enjoy other things as well. Thanks for coming, and I'll see you in the next webinar. Bye-bye.